Okay, dear students, this is Dr. Maya Done, and I'm talking about the phase changes, how it changes the phase, and it's a physical change. So in this slide, you can see solid. The easiest way you can think of the phase changes is think about water. Water is it is in ice form, and this is a liquid water, and then this is like liquid, and then it goes to the water vapor. So water changes from solid to liquid. Let me get it. What you call water changes from give me a minute, I have to open this one. It's okay, right? Okay, so the easiest way to know is, so you have ice. So you have ice, and then that's a solid, and then you have liquid water, and then this is water vapor. So in ice turning to liquid, that is we call the process we call melting. Liquid water becoming water vapor, we call boiling. Or so it's vaporization. And then the other things, when you go back, water vapor becoming water liquid, you call condensation. And then liquid water becoming ice, you call freezing. Call it freezing. So, and then there is another two things you call a sublimation and deposition as well. I'm gonna come to that in a minute, but let's see how are any of these processes, how we can classify these processes as exothermic and endothermic. So think about ice becoming liquid water. In order to for the ice to become liquid water, do you need to provide heat? So they absorb, right? Ice absorb heat. So then that process is, let me get another good color. That process is ice becoming a liquid. When ice becoming a liquid, we call that process as it absorb heat. It's endothermic, because you need to provide energy to the ice to become melt. Similarly, liquid water become water vapor. Liquid water absorb heat, right? Any time, whenever you absorb heat, that is system absorb heat, that means they have higher energy. They absorb heat is energy, so when they absorb it, it has higher energy. We call that is also endothermic process. And then the other way, when the condensation, which is water vapor, become liquid water. When water vapor become liquid water, it is the other way, which is when the water vapor become liquid, it releases its energy to the outside. So this is exothermic process. Similarly, the liquid water become ice. Again, it releases, because ice is more colder than water. When ice is more colder than water means it releases its energy. Cold means less energy. You have heat means you have, like, it's hot means you have higher energy. So this is also exothermic process. So that is important. You need to know what are the phase, like solid, liquid, gas are the three phases of matter. And then melting, which is the solid, like ice become a liquid water, you call melting. And then liquid water become water vapor, you call it boiling or evaporation. And then these processes are endothermic, while condensation and then the um, freezing, these are exothermic processes. And then go back. And then when you go to the your slide, it says, okay, vaporization is endothermic. So you see, it's a transition from, that's what we just discussed, liquid to gas vapor. It occurs when the molecule in the liquid have enough energy to break the free intermolecular forces. So it's endothermic. You need to basically know what is vaporization. Is it endothermic or exothermic at this level? And then this is condensation. Condensation means, like, you see condensation in the morning, right? That you, when you touch a little of like paper, you see on the top little bit of water droplets. That is condensation. Water vapor become liquid. And then that condensation is exothermic. So, and then there's one more two types of physical changes that I didn't discuss, which is sublimation. Sublimation is the directly from solid to vapor. And then the deposition is, it changes from vapor to solid. These so the sublimation is endothermic, right? Because it's, you need to release its energy. Sorry, it absorbs its energy, but in deposition is exothermic. And these, we mainly use the sublimation to make frozen food. And that's about mainly about the phase changes, which is very important. You need to know. Let me explain this table, the diagram. So here you see solid, liquid, gases. You see solid become liquid, you call melting. Solid becoming a liquid, melting. Another word for melting is fusion. Temperature is increasing. These things happen when the temperature is increasing. Temperature increasing means you need to provide energy to the system. Think about the beaker. You have ice. You provide energy. Then only it's melting. So when you provide energy, that means that ice absorb water. Anytime when it absorb water, we call it endothermic. So this is melting, and then you provide more energy, then it's become gaseous, so we call it vaporization. And then the other side, you cool the system, and then gas becoming a liquid, you call condensation. And then liquid becoming a solid, called freezing. You bypass this liquid directly, solid becoming a gas, sublimation. Gas becoming a solid is deposition. So this is how these phase changes. And then you don't have to you don't want to know about any calculations at this level, but I want you to know the theory behind it. And then I also want to show you three more things here. The physical properties of the liquids, which is viscosity. Viscosity is resistant to flow. Surface tension, like viscosity you can easily see. Like think about water and honey. Honey is more viscous. And then these viscosity increase with the increasing the mass of a liquid. Anything, the boiling, these all the properties. It can be a boiling point. It can is increased when the weight of the molecule increases. These properties also increases. And then surface tension you see on the water body. You can see little animals can, like little insects can walk. And if you take a water cup and put it like a clip, like a paper clip, it can float. That is because of the surface tension. And then boiling point, the substance are very high in vapor pressure, we call volatile. Example, you go to the the vapor pressure means how easily the liquid can go to the vapor phase. You go to the the gas stations, you see the gas, you skip the smell because they are very vaporized, very volatile solutions. And then so that's about it, the boiling point. And then in this question, they say select the compound with the higher surface tension. Um, this is, you don't want to worry about the naming. It's like a C1CH3OH or like this bigger compound. So at that time, the higher the surface tension, ha- so the both this compound has the hydrogen bonding. So when you have two OH, that means this compound has more oxygen, so it can have more bonding, more hydrogen bonding. So whenever you have more hydrogen bonding, that means that has the like you can form the hydrogen bonding with the oxygen, nitrogen, and fluorine. So it has oxygen, so it has high lot of hydrogen bonding, so that has the higher surface tension. Okay, I hope this helped you to understand chapter 7. Thank you.